It's summertime.
That means it's time to hit the lakes and rivers for some summer fun.
Those are huge!
I spent a little time recently making something to maximize your summer fun potential. Simply put, it's an easy way to make any surfboard or paddleboard motorized. A mostly universal motor mount. I made this mount because pre-built boards are on the very expensive side. We're talking around $5,000 on the low end, all the way to 20 grand or more for certain e-foils and jet boards. Thankfully for us though, FlipSky already makes basically all the hardware to build your own. This motor mount is just the first of 3 parts, with the ultimate end goal of maximizing your summer fun potential on a budget using your 3D printer. Let's go ahead and run through the main components of an electric surfboard really quick. First, we have our board, of course, which really can be any size you'd like as long as it can hold your weight. I used a 10.5 foot fiberglass paddleboard for my build. Both surfboards and paddleboards can be found on good old Facebook Marketplace for next to nothing. Then, we have 2 large IP67 enclosures that you can easily find online. One holds the batteries, and the other holds the water cooling components and speed controller. Next up is, of course, the bread and butter, the motor and motor mount. Then, we have the plumbing. I used a little 12-volt water pump connected to a butt converter, and then ran a 1/2-inch PVC pipe through the board itself to act as water intake underneath so our speed controller stays cool. Some speed controllers you can just directly submerge under your board. And finally, my favorite part, a FlipSky V5 remote. Thank you FlipSky for sending this to me. It's got a digital screen, GPS ride tracking, live speed readout, and tons of telemetry features. Now, some of these parts can be on the pricier side, but there are a lot of alternatives at a wide variety of price points to fit your budget. You can easily upgrade them down the line too. My first motor mount was made on my resin printer and worked great, but resin is a pain to print with. Version 2 was all FDM printed and suffered catastrophic failure, unfortunately. And finally, version 3 is majorly reinforced with aluminum for maximum durability. Now, about the motor mount a little more. I settled on ASA and PETG for the filament options because both handle heat, UV exposure, and water well. Version 2 snapped because of some poor geometry comboed with hard cyclic loading. The full ASA mast was just too weak, which is why with version 3, I went a bit overkill and made a 1/2-inch by 3-inch by 8.5-inch aluminum bar, the load-bearing component, inside of the 3D print. So the 3D print is more of a shell at this point, and it works great. I also reinforced the base plate too with some aluminum pieces. Before I show you the day at the lake with the latest version of the motor mount, I wanted to say massive thank you to FlipSky for sending over parts for my project, and also shout out to Sunlu for supplying me with a ton of filament to get all the testing done. Alright, it's finally time to go out on the lake. I started off with a quick prop test, which failed miserably. So I went back to the stock prop, and in order to do so, I had to do some quick software changes, which involved making a tent out of my towel so I could actually see my laptop screen. Alright, we're out on the water. We'll put it in low. We top out at 5 whole miles per hour. Medium, ooh, immediately puts us into plane. 9 miles an hour. High. Oh, I forgot I don't have my fin on. Oops. We're at 10 miles an hour. I should go get my fin. Aish. I'm going into the wind. Ow, my butt. I've got to get aerodynamic. The mast is a bit of a control surface because it is pretty hydrodynamic, but you get this oscillation when you're not like focusing, and I want to be able to have it locked in better, and that's what that fin will do. All right, we've got our fin on. Just one is enough. Gives me enough turning authority. Sweet! Then we can get this back in the water. But the mount seems to be holding up great. You know, we've got the 4 M6 screws in a 2x2 grid, and they're stainless steel hardware. And those go through the 3D print, and then the 3D print is using these 1/8 inch pieces of aluminum as basically big retainers, because instead of the bolts being held in by just the plastic, now the threads have gone through the aluminum, so any force is transmitted along the length of this aluminum stock instead of just in the little M6 holes. So this is a big reinforcement, these 2 plates on each side. And then of course the mast has a 1/2 inch piece by 3 inch like that of aluminum, and it goes all the way up to about here. There's about a 1/2 inch at the top that doesn't go to. So really the structure is the aluminum on both the base plate and on the mast. All right, we're going back on the water with the fin now. Okay, I get it, you're fast. I want to get away from the weeds. We'll try to go to the end of the lake and then come back and see if the battery dies or not. And we're up. You just feather the throttle a little bit. You get on your knees. You stand up, because once you're at speed, it becomes a lot more stable. So once you get past the like 6 mile-an-hour point, you can go from your knees up to your feet. Woohoo! It handles really well though. It's like riding a longboard. It's about the same amount of turning authority. Oh my god, it is so nice to be on the water when it's like 90 degrees out. Woohoo! That's some solid weight. It's a little bit of a rooster tail. I'm glad there's no rocks to hit in the middle of this lake. So this is Ruth Lake. It's in the middle of nowhere and I'm in the middle of nowhere. So it's kind of nice that this place exists. That ridge back there is actually called South Fork Mountain. And the fun fact about South Fork Mountain is it is the longest ridge in the entire world. It is a 60-mile continuous ridge, and that is very, very long. I should probably start turning around. I'm not overly confident because I'm only running 2 batteries at a... Oh no. Oh, this is the hard part. Did I make it? Did I beat the angle? I beat the angle. Oh my god, the wind's picking up. Woohoo! It was so calm on my way down. Ooh! These are big swells. Alright, we've almost gone a mile. That's pretty sick. So this motor combo, even with the stock prop, is pretty efficient as long as your board's not too heavy. Mine's on the heavier side. We're getting close. Can we make it on the charge? We're at exactly a mile. Not bad. Oh no, I'm slowing down. I'm gonna eat it. I think my battery's finally dying. All right, recovery. So I almost got, between the testing that I did and this trip, I got about 2 miles for about 500 watt hours. So 250 watt hours per mile. Not horrible, not great. Or it might be it's probably close to like 300 watt hours per mile. So not that great. Gonna be honest, not that great. Oh, there was a weed. Oh.
Those are huge.
Anyways, that's all of my GoPro footage from the lake. Thank you for watching. The files for the mount will be posted to Printables, and the next portion of the project will be out soon. See you then. Bye-bye.